This is
Exclusive hot.
Welcome all to this episode of the Why to How podcast, where we explore adventures in STEM. After an amazing Canada-wide science fair a few months ago, I wanted to check in with our Platinum and Best Project Award winners to learn more about their science fair projects and the adventures they've had along the way. Today, I'm joined by Max Du, a grade 10 student from Calgary and our Intermediate Platinum Award Innovation winner at Canada-wide Science Fair 2022 for his project, a novel pre-hospital indoor rescue drone. Max, welcome to the podcast. Did you want to start us off by introducing yourself a bit and briefly explaining what your project is about?
Yeah, good afternoon, Stuart. Thanks for having me here. My name is Max Du. I'm currently a grade 10 student attending Western Canada High School in Canada, in Calgary, Alberta. And I attended the Canada-wide Science Fair when I was in grade 9. And my project is an innovation of a pre-hospital indoor rescue drone. The challenge I was trying to solve was to help rescue more cardiac arrest patients at home before the EMS arrives, including those who are home alone. For people undergoing cardiac arrest at home, which means that the heart stops beating suddenly, they may die within 10 minutes. Only 10% survive. If they are home alone unwitnessed, only 4% survive. When I noticed this 10% survival rate has been low in the past 30 years, it is unacceptable, especially because it is the third leading cause of death. Then, I looked at current solutions. They are limited. This is a problem worth solving, so I set out to innovate a pre-hospital indoor rescue drone. The drone is designed to be used indoors, like a personal drone in a home, and it has 4 designed features. The drone will first activate when the patient presses the emergency button on their chest, in the situation of a cardiac arrest. After, it can locate and approach patients in seconds, upstairs or downstairs. Then, it enables surveillance connection with an EMS team and delivers life-saving medication to patients under surveillance with a pillbox and an intramuscular autoinjector. The drone can also open room doors to approach patients with an extendable arm. I hope that this innovation can increase survival rates, shorten recovery times, and reduce healthcare costs.
Cool. It is a really cool project. I mean, I had a great time exploring your project board account, watching the videos and looking at the photos of this little drone with all your pieces built on top. What a cool idea. I mean, what a fantastic invention this is. Do you want to tell us where your idea came from?
Yeah, my idea really started from the passion I had with drones. I like drones, and they are like unlimited possibilities for advancement and development in the future. I knew this from my experience last year when I designed a delivery drone in the Real World Design Challenge and realized that we can use drones in so many more aspects of our lives. Not only just to fly around recreationally or take cool drone shots. They can do many things that humans on the ground cannot do, and robots on the ground cannot do. So when I got a drone for Christmas and I couldn't fly it outdoors because of the cold weather and COVID-19, I had to fly it inside of the house. So I got inspired, why not make a drone more like a flying robot, like an indoor helper? So after I did some research about heart failure and cardiac arrest, the 30-year low survival rate, and limited current solutions, it really motivated me to start innovating.
Cool. Yeah, and lots of innovation. I mean, I've got a drone. I never thought about putting this stuff on it. So what sort of drone have you got?
I have a DJI Mavic 3.
Nice. And did you find it difficult to fly inside?
No, because of like how stable the technology was on that drone. I found it pretty easy just to fly it inside.
It's really good, isn't it? Like it's crazy stable, and lots of like object detection and everything built in too. Yeah, really, really, really cool. So you said you did a bunch of research and you learned about the risk of heart attack and the risk of heart failure and the low chance of survival. Where did you learn about all the things you needed to then build a solution and put it onto a drone?
A lot of these were like self-taught. Like many days I had to stay up late searching on Google, reading on Google Scholar, and watching tutorial videos on YouTube. And I looked through a lot of different textbooks, not even just for like the heart research, like even finding out how to calculate the equilibrium point on the assembly for the center of gravity. I had to go through AP physics textbooks just to figure out how to calculate that. I also like to share that like the summer camps that I attended were really helpful in this learning. So, for example, last summer I attended the Stanford AI for All program, and I was lucky to be one of the 32 kids selected. And I had the opportunity to learn about artificial intelligence and machine learning. And this program was like a huge eye-opener and inspired me to think more about how I can empower my drone using medical AI. I also went to a Penn engineering summer camp where I was lucky to be taught like university level engineering directly from Penn professors. And this learning really helped me to redesign and optimize my drone.
Nice. Where did you learn about these summer camps that you did?
I think I just like searched online because I was really interested and I didn't want to like waste all the time I had in the summer. So I just searched up like some summer camps and I applied and I got in. So yeah.
Congrats. Nice. Yeah, what a great way to spend your summer. Was there anything from those summer camps that really stuck out to you? Anything that's super memorable? Something that you're very grateful to have done them?
I think the summer camps, like in general, like the final projects, the capstone projects, all of these, like they really let me learn more how to improve my drone. So I think that's a point that I'm pretty thankful for the summer camps. Yeah.
Nice. Yeah, cool. So back to your drone then. What were the main pieces of this drone? So what were the main pieces of your project? So obviously you've got the flying the drone itself and obviously the equilibrium of all the physical pieces that you built on top of the drone. And then you've got the electronics and the software. So talk to me a little bit about like all the different pieces that went into building this project.
So I think like hardware wise, we can split it into 3 different parts. One is the arm and the gripper system. The second, the electronics, and lastly is the auto injector system. So starting off with the arm gripper system, that I went through 4 separate designs for the arm and 3 separate designs for the gripper. And I really had to go through a really intensive iterative design process in order to achieve the result I wanted. The electronics part was more of finding the correct electronic board that I could use to help my drone like do all of these commands and like push out the result of actually be operational. And finally, the auto injector part, I used a linear motion device on that in order to extend the injector out. And that part was challenging because I had to really optimize the weight of that piece because it had to be light to achieve that equilibrium. So a lot of the first ideas that I had about like motion control and motion detection, I couldn't really use because those would require a lot of weight and a lot of separate parts. So I decided just to hard code that into the software, and it worked out pretty well.
Nice. That is a lot of different pieces. When you were putting together this project, did you work on the arm first and then the injector bit separately? Were you trying to do it all at once? Was the injector first and then the arm was just like an extra piece you added on at the end? Like, step me through the thought process on how you came to doing all of these different things.
I think when you start like an innovation project, especially for me, I went through a design process where I first came up with what I wanted the drone to achieve. And then I thought of like each part. For example, I wanted the drone to be able to open a door. So I thought of 4 different arm systems and 3 different grippers that I thought could be possible to achieve what I wanted it to. So, and then I went through an iterative design process, which included like low fidelity testing, for example, like just folding a piece of paper and seeing if that method would work. And it really narrowed it down. And then we moved on to the prototyping process, which was fabrication of these with like stronger materials that can actually handle what I wanted them to. And it's really like a system level design where like after all these steps, you would achieve something that like you haven't achieved, right? Mm-hmm. And then I think after testing all these prototypes, I was able to get the final result. In terms of like the order I did it, I don't think I had a specific order in mind. I just like whenever I had an idea or I had something that I wanted to test out, I kind of just tested it. So I don't think that there is some specific order.
Mm-hmm. I'm guessing then you were probably testing a bunch of ideas, and some ideas might not have even made it in. So were you testing quickly, and like how did you go about that testing phase, and how do you know when to pursue one idea versus just cut it and move on to the next idea?
I think I had like a checklist, and there are some like I just go down that checklist and see like if there were some major like red flags or if there were some major issues with that design. For example, like the first thing I would have checked was the weight of it. How heavy, once this has been prototyped, how heavy should it like would it have been, right? For example, I had to eliminate some of my arm designs because those designs needed metal extrusion, and that is like extremely heavy, and the drone would not be able to handle that. I kind of went through like subsets one by one and considered them as a whole. Like I tried combining these two different subsets and seeing if they would have worked with each other, if they would have complemented each other. And yeah, that's just how I decided. Also, low fidelity testing, it really helped. Like you can kind of determine how well a design will work just based on using like simple materials like popsicle sticks, paper, rubber bands.
Yeah, that's really cool, and I think that's a very key thing that maybe a lot of students miss is that they aim for perfection from the get go. You know, right? There's a huge amount of effort involved in something, and then when it breaks, all of a sudden they're having a crisis because it's this massive big thing that they were just hoping to work. Whereas you really, were just using very simple things like popsicle sticks and just making sure that the theory worked, and it worked, low fidelity, as you say, just worked on a very simple theoretical basis first before you then decided to spend, more effort in building something a little bit more complex or a little bit more, structurally sound or something like that. So that's a really, really cool way of doing things. I'm curious also to know, how did you keep track of all of this information? So obviously, you're doing things with the arm, the drone, the software, the ejector. Were you keeping track of it all just like written down in a notebook? Were you using some program on your computer to keep track of all this information? Like where did you store all of this content?
I guess I just stored it on like a Google Doc. There's my logbook, right? Like every day after I finished like my session with doing this project, I would just kind of type up a summary of like what I did, what I accomplished. And that was kind of how I kept track of my day by day. But I also had a checklist on Google Docs, Google Docs. And I had to manage my schedule by using an agenda. So those are kind of the different methods that I use to keep part of my keep my project.
Making sure there's some structure involved so that you're not just got a piece of paper here and something written on an Apple Note over here and then a Google Doc over here. So trying to keep it all in the one place and have a checklist. Yeah, nice. I like that. So I can imagine you had a few mishaps and challenges along the way in this project. Do you want to talk to me about some of them?
Yeah. So like there are a couple of big challenges. And there are a couple like general challenges. So speaking of the general challenges first, I had like this project in general was just a huge challenge for me in the skills that I had, like knowledge, skills, and resources. For example, for design challenges, I had to constantly try to minimize the assembly size and the weight just to make sure that the flight was balanced. I also had some learning challenges where I had to learn new concepts of mechanical mechanisms and electrical engineering. I also had to learn like CAD design, C programming, Arduino control, and 3D printing, and a lot more. And obviously, a lot of this was really expensive, so I had to minimize the cost. And I was resourceful. So for example, I used my mom's selfie stick to be a part of the ARM system, and I took my dad's camping air pump just to test different auto injector designs. I also had to run between 3 different locations just for 3D printing and fabrication of some of my parts. A huge challenge of it that I think I kind of overlooked a bit was the time management involved. I had to be extremely good at my time management in order to balance my schedule. For example, I had to get up really early in the morning just to double check my CAD designs details and like send it to the 3D printing and fabrication right before I went to school. And late at day, almost till midnight, I had to learn hard new concepts on mechanical systems, electronics, Arduino control, and sometimes even test parts on the drone.
Nice.
And yeah, I can just go into a couple of like big challenges, for like examples in my project. So a big challenge was how I solved the arm gripper system design. So after failures of like 4 different arms and For example, I had to drop like my pulley arm system design because it was too heavy for the drone. I had to work out alternative design. So I had to drop off the air pump design because it did not have enough tension when it was inflated. And similarly, I failed 3 different separate grippers, and I was totally stuck in this. So for this challenge, I ended up solving it using an out-of-the-box thinking, and I solved both the arm raising and gripper support issue by like capping the gripper and then landing. Another big challenge was to solve the flapping flight issue. When testing like the drone with a full assembly, the drone was kind of flapping in the air. I'm sure you can see that in the video, which caused an unstable flight and an unstable landing, and it actually ripped the propeller off. So for this challenge, before I came up with the solution, I spent a lot of hours trying to dig deeper and find out the reason and find out the root cause of the problem. And I found myself learning like AP textbooks to calculate the center of gravity, and that really was an amazing like solving through learning experience.
Yeah, I mean, you definitely don't want a drone flapping around when you're trying to inject someone with a needle. I feel like that's health and safety 101. That's not in the box of the drone, is it? Prabner in the Discord chat wants to know, how long did your project take?
My project took 4 months, but I still have like some parts that I want to like improve. So, like, I guess I plan to improve in like aspects of design, cost, and collaboration. Like I want to improve the arm gripper operation and simulate live video surveillance systems to connect to the EMS communication over a long distance. But my project took around 4 months, but I plan to keep improving this project after Canada-wide Science Week.
Nice. And so by 4 months, is that when you first came up with the idea to when you finished it and sort of had it ready for regional science fairs, or is that when you first started working on it?
Yeah, it's when I like first had the idea to the final product. Yeah.
Nice. And throughout this whole process, what was the hardest part of your project?
I think the hardest part was that I think just like persevering and trying to I had a lot of parts where I was just stuck on that specific part for days, right? Mm-hmm. I had to persevere to just keep on going and keep on trying different ideas and persevere and keep on testing and not get my spirits down even when I had failed so many times. I think just keeping my perseverance and interest in it was a pretty hard part.
So how did you stay interested? How did you stay motivated?
I think just I wanted to see the final result. I didn't want to have a half-finished project and just kind of quit, I guess. So and plus I was really passionate about my entire project. So I was really motivated to find the root problem and to solve it. And also I had a bunch of outreach. I asked a lot of people for help and they gave me they made me super motivated because I got responses from these experts and these people that you never would have thought could reply to a cold email. And for example, when I emailed that doctor about my questions about emergency medicine, I not only gained knowledge, but I also felt that what I did mattered.
Mm-hmm. Nice. Yeah. So you connected a reason to your science fair project. You're not just doing it just to do a science fair project. You were doing it because of this reason that you felt inside that your project mattered. It actually meant something to you and to other people as well. So that definitely, I'm sure, helped the perseverance. So yeah, let's talk a little bit more about who these people were that supported you through this project. You mentioned, reaching out to a doctor using cold emailing, but was it other mentors or supporters throughout this project that helped you along the way?
Yeah. So I got great support from my robotics team, not only suggestions on mechanical and electrical engineering, but they also let me use their build space and they let me use all their large machines such as hydraulic presses, bandsaws, drills, all these things. And they gave me a lot of spare metal and parts. So that was super thankful for them. I also got a lot of support from my school. my principal, Mr. Errol, and my science teacher, Miss Hewitt, and they were really supportive of me, and they basically let me have free range over the school's 3D printer. So that was really helpful. I also outreached and approached doctors and professionals. Like I cold emailed them after I read like the relevant research papers, and it was normal that I never got a response because most of them are like crazy busy and they wouldn't bother like responding to a teen. But in the end, there was always hope. For example, I cold emailed like Dr. Michael Tumansky, and he was like a well-known neurosurgeon and an inventor of this medication called NA1, and he helped me confirm the application of NA1 in EpiPen delivery.
Cool. Do you want to describe a little bit about what sort of information you included in these emails? So for someone who has never just cold emailed a professor or a doctor before, what did you put in the email? How did you go about that process?
I think just like you have to first like be confident enough in your ideas that you know that like when you cold email it, it won't be embarrassed. So I read his research papers on NA1. I kind of got like oversight about exactly what he was doing, what his field is, and what he's an expert in. And then I asked specific questions in the email. So I didn't just ask like a general question like, what is NA1? I asked, what is NA1 and how can I apply it to my project? So that was kind of like and then it was kind of lucky because he was also a bit interested in using like indoor robots to help with this. So I got lucky because of that. And yeah, just be very specific in that email and know exactly what you're asking and what the person you're emailing is an expert in.
Yeah, so I think the key takeaway there is you're not emailing these professionals about stuff you can find out online. You're emailing them to ask their perspective, their opinion on how to attach that core piece of NA1 that you mentioned and bring it into line with what your science fair project is. And it's them providing their opinion, their knowledge, experience, all the things that they've learned throughout their life. And making that application is the key piece, I think, there, as opposed to the mistake I see a lot of students making is that they're just asking a question like, what is NA1 to someone who is probably very busy in their life? So identify that key piece that you can actually gain from them and help them feel like they want to help you because of some cool little science fair project that you're doing, which it is. It's a really cool science fair project.
Yeah, exactly. Yeah.
So talk to me a little bit about your project then, your conclusion. What did you find? Why does it matter?
Okay, so since my project was like an innovation, my findings were more about like how did I get the final prototype to work. So when I first started to do the project, I didn't really have a whole knowledge about assembly weight distribution and the center of gravity. And I didn't really know that it would be such an important factor. But after several failures, I discovered that it is extremely important to control the assembly weight, size, and position placement, because even a very slight adjustment for a single part could cause like huge flight instability. And I had to be very careful in terms of material selection, center of gravity calculations, and mechanism redesign. And later, I discovered that like further, just by using a simple physics calculation wasn't enough to solve the issue, because you had to think of the problem in 3 dimensions and you had to take into account what like the perfect physics world didn't account for. So using the physics calculation I did, it was kind of assumed that everything was like the same height and there wasn't a drone at the bottom trying to keep everything balanced. So this process was probably like the longest one, and it almost took me an entire week because I had to consider like the height, the weight, and I had to like constantly shift the entire assembly. A huge like migraine for this one was the arm, just because it was so tall that it would constantly shift the center of gravity backwards. So I constantly adjusted that weight distribution, and I took apart and reassembled a lot of it. And even just a couple of millimeters of adjustment mattered. I made it just a bit more stable. But when the drone like finally took off and flew balanced and kept stable, it was incredible. And I was really happy after that. Another part I think of discovery when I think of my innovation is just like the auto injector's movement mechanism. I discovered that like linear motion is a hard process to control and actuate, especially when you have such a strict weight limit. Like you have to be able to track where exactly and how far you've moved the arm so that it doesn't like snap a string. Um, I tried like using a lot of things like I tried experimenting with a lot of different ideas like encoders, photo interrupters, mixed with rack and pinions or linear lifts. But in the end, I discovered that these motion tracking methods required a lot of space.
Mm-hmm.
Like for example, a photo interrupter that required a wheel that constantly span, and like there's a light and it would just detect once like when a piece of black like reflective or a piece of reflective went over it, and it would detect how many ticks it would have been, and you could have known. But that was super heavy and it required too much weight. So I just decided to hard code it in and just base it off of time just to track how far I've gone. And I ended up using a modified linear lift system to keep the smooth and accurate movement. And this method actually worked. And it reached the distance that I wanted to and injected. So I was pretty ecstatic because I took a lot of these days of research, coding, fabricating, and testing, and it finally all paid off.
Mm-hmm. It's wonderful when it all pays off like that, isn't it? Especially in a project like this where there are just so many real world applications. But do you want to go into that a little bit? So like, why is this project important? What are the real world applications of this project?
Yeah, so in terms of like importance, I think any of our loved ones who are at risk of cardiac arrest would love this like novel drone at their home because it's standby, it's 24/7. They can be rescued faster, and even in the case that they're home alone, like this instant like emergency medication delivery within 6 minutes is critical to save a life, and is significant to avoid like neurological damage. Second, it's super important just to bring up that like it's an innovation solution for this challenge, like because in the past 30 years, the survival rate has been low and it's been the third leading cause of death. And this is like the first indoor pre-hospital rescue drone, and it proposes a new innovative solution to help save cardiac arrest patients. So I also think that it's important for tech as advancement. Like this project expands the availability and compatibility of unmanned aircraft in indoor emergency rescue. And it's impossible that the novel tool process can be adopted into current EMS systems and create more efficient emergency care and outcomes.
Mm-hmm. Nice. Such a wonderful project. What did it feel like when you had done all of this work? You had put in all of this effort to design the 7 different functions of the drone, and that very first time that you finally got it to fly in the air and deliver an ejector at the right distance, and all the pieces just came together properly. What did that feel like to you?
So like, as I mentioned before, like it was really iterative. Like there was design, build, test, fail, fix, retest, right? And I didn't really know if the next test would or would not work. But when it worked, it was like kind of sudden, but it was an immense feeling of happiness. Like it felt incredible that at that moment, every part seemed moving smoothly and every issue seemed so simple. Even though I had struggled for many days, it felt that my hard work had finally paid off, and it was worthy that I had challenged myself, and I was worthy that I had persevered. I think that I felt super proud of myself for some of these because, like, thanks God that I did not give up when I got stuck on those difficult challenges.
Mm-hmm. No part of you were just like, I wonder if I could build this extra thing on top of it now. So then what did it feel like when you're at Canada-wide Science Fair and all of a sudden your name's being called out for a Platinum Award?
Actually, during the award ceremony, I wasn't really able to participate because I was in a chemistry test, and it was like a perfect overlap in time.
Yeah.
So I didn't hear when they were announcing the awards and that I won, but I was kind of clueless for that for like an additional 30 minutes after. But after the test, I checked like my messages, and a lot of my Calgary-wide Science Fair teammates, like they were telling me about the awards that they won, and they were all really excited because I had won this big award. So later, when I was eating dinner, I watched the replay of the live stream with my sister and my parents. Mm-hmm. And although it was a replay, when they announced my name, it was really exciting because like this was my first time participating in Canada-wide Science Fair, and I didn't really expect any awards or prizes. I kind of felt like I could have just gone to the regional level and I would have been done. But I felt ecstatic because I had put a lot of hard work into this project, and it feels good to see like something that I did get recognized.
Yeah, I mean, congratulations. Honestly, what a wonderful achievement. So you say this is your first time competing at Canada-wide Science Fair. We've got a question here from Pay Malone in the chat. He wanted to know, when did you learn about Canada-wide Science Fair, or did you just like wake up one day and decide, I'm gonna do it?
So I learned of Canada-wide Science Fair from my teacher, Miss Hewitt. She was the one that organized the youth science fair team at my school. I kind of, when I went to the youth science fair, there was like, I heard some like talks about like Canada-wide Science Fair, but I really wasn't that interested in it. But after like I got that like travel award where I represent like Team Calgary to go to the Canada-wide Science Fair, that's when like I started researching more into this competition, and it's very, very interesting and very great that there's this like national science fair.
Mm-hmm. Did you know much about just science fair projects in general before you started?
I had made like some science fair projects in the past, but I didn't really take it that seriously. Like it was just kind of like I did it at school, just as something that was fun. Not really science fairs, but I had participated in a lot of like previous competitions. For example, I participated in a science research competition in grade 7 and grade 8 with some of my school friends, and it was called the Mud Watt. We basically researched mud as renewable energy source and how to use that to generate enough electricity to light a light or light an LED. And that was really my first like sight into the entire scientific research process, from data research, field collection, daily experiment observations, report generation. That was my first time experiencing an entire scientific research process. That really like engaged my faith in science research, and from then on I shifted my focus to a lot about innovation and scientific research.
Nice. So after all of that, after Canada-wide Science Fair, after doing a couple of different projects, what's your favorite part of Science Fair?
I think the favorite part of Science Fair was like, since this was my first time attending Canada-wide Science Fair, it was such an amazing experience. Like my favorite part was just knowing like so many new friends that were really passionate about science across Canada. And like, although like regrettably it was online, I can still feel like their enthusiastic, like, and their enthusiasm and their curiosity. And it was really influential and inspiring browsing through their projects. And it was just really eye-opening experience and made me excited and think deeper.
Do you think there was something different about your science fair project this year that made you want to commit to doing a full project? You said you've done science fair projects before, but was there something different this year that made you really want to dig in, persevere, and make something wonderful?
I think just like from more previous experiences with like the real world design challenge, where I was able to research more into drones and engineering, as well as like my passion for like drones and flying things. Like I think that even when I was really young, like my kindergarten science fair project was about paper airplanes and how like I researched how far something would go based on the length of the wing.
Yeah.
I think that this project that I did differently was just like I was a bit more invested in it. I followed more proper like research, and I just was a bit more interested in this topic, I guess.
Yeah, it sounds like just a lot of things came together for you all at once this year. You've had these ideas and you kind of knew what you were interested in, but this year, you sort of found yourself in a place where an idea caught your fancy. It also happened to do with something that you're super interested in, and you got a drone for Christmas. So all of these things sort of like all came together to provide you with the perfect foundation for just being like, hey, I love flying drones. How do I make this cool? How do I do a science fair project about doing something that I care about and saving lives, basically?
Yeah.
Do you think there's something unique to you that got you a Platinum Award winner, something that maybe other science fair students need to think about to give them the best shot?
I think just like you got to choose a topic that you're really interested in. Because if you're just choosing a topic that you think like, oh, someone in my previous science fair won, or like something that a teacher recommended to you, like you aren't going to be that interested or invested in it. You're not going to spend as much time that you quite want to spend on it. And like you just have to choose there's only one answer, is that you just got to choose a topic that you are interested and you're willing to spend time and be invested into.
Exactly. Yeah. Talking about your project again, we do just have another question from Prabnor in the chat. Wants to know, do you think you could add a part to do chest compressions to your drone?
Yeah, so this is also a part that I explored when I was first researching about this drone. So there's like chest compressions, and there's using a defibrillator. So mainly for these challenges is that how are you going to be able to locate the correct spot on the patient, right? Like they may be in difficult positions, like sometimes they may be sideways, or sometimes they may be even like face down. Like you can't just attach a defibrillator on someone's back and expect it to work, because that would just end up making their condition worse other than better. So I think in the future, as technology progresses, there will be a possibility for this. But currently, with the technology that I'm aware of, I don't think that I can apply to this drone, especially because like defibrillators, they're really heavy, right? The least weighted defibrillator I could find was around 1 kilogram, and my drone's weight limit was 600 grams or 800 grams. So you kind of need like human support there. So
yeah, exactly.
Yeah.
So what comes next? Are you still looking at expanding on this project again? Are you going to try to do a different science fair project this year? What's the plan here?
For what comes next is like I have not stopped exploring this project after Canada-wide Science Fair. There's still a long way to go in terms of expansion and improvement of this project, I think. For example, I plan to switch all my electronics to a more advanced system using ESPs instead of Arduinos in order to reduce the assembly weight and power consumption and just optimize that electrical design. Recently, I've been focusing more on the real-time surveillance and remote control, because these functions have more weighted influence on faster and more effective rescue. And the surveillance system helps the EMS to know the patient situation and precise indoor location, and that will create like faster rescue. I also want to solve the wireless connection between cardiac arrest patients and EMS teams, which can be more effective for life-saving and maybe possibly enable rapid diagnostic before the EMS can arrive. With what I learned from the Stanford AI for All program, I also envision great opportunities to apply possible power of medical artificial intelligence and machine learning and drone networking. I also plan to file a patent for the device and the approach based on the current validation of the prototype. In the long term, I plan to do some further research and refine for potential application extensions to benefit other patients at high risk. For example, diabetes patients may experience diabetic comas, angina patients, and high-risk allergy patients.
Sounds like you've got a whole lot of things to focus on still. Yeah, there's a lot more to come. So how do you decide then what to focus on next?
I think just based on like application, right? Like you have to know what the medical community really wants. Like you can't just innovate something that no one's going to use, because the application is a bit narrow, right? The functions like real-time surveillance and remote control, they had a more weighted influence when I interviewed doctors and engineers, and they said that would help them create a more faster and effective rescue. So that's currently what I'm focusing on.
Yeah, it makes sense. I mean, when you have a limited amount of time, energy, capacity, you want to get the best bang for your buck, basically. So what can I do that has the best impact with the lowest amount of input, especially when you are under time constraints for science, regional science fairs, especially when you've got school to do still. I mean, this isn't your full-time job, right? So yeah, lots more to come, and I'm excited to see where the project takes you. Was there something about the whole science fair project, something about this project specifically, or just like something that that probably caught you by surprise a little bit? Like, what did you learn throughout this whole process that you weren't expecting to?
I think I kind of mentioned this like before, but I think I learned just a lot about like new concepts or like a lot of technical things that I learned. For example, since like in innovation, it covers a lot of disciplines. Like it was challenging for me in my aspects of knowledge and skills. So I had to learn like new concepts of mechanical mechanisms, electrical engineering. I had to learn system level designs like CAD design, C programming, Arduino control, 3D printing. Like I even had to learn a bit about emergency medical medicine and medical delivery. I had to learn something about like Health Canada's medical devices regulations and even some business knowledge about startups to how to commercialize a innovation. Those are just like the technical things that I learned. I learned a lot of just things like learning how to come up with ingenious ideas by thinking outside the box. Like doing this project, I learned a lot of topics and topics related to those topics, and it's kind of like a rabbit hole. And by figuring out how to solve the issues that my innovation had, it allowed my mind to go outside of the box and for me to think about solutions that were creative and that worked. I also learned like you have to persevere and you have to continue going because like I found that when you continually repeat something, like for me, it was exploring and refining new prototypes and continue to make new prototypes. I learned that continuing to refine and explore, you can create what you like never thought you could have.
A lot of lessons there. Exactly. I mean, that's you're like the poster kid for why project-based learning is so wonderful, and that's exactly what it is. It's a rabbit hole. I mean, the good thing about project-based learning is that you find something that's interesting to you, it captures your attention, and then all of a sudden you're wanting to learn about all these different things and how they apply to one another, as opposed to learning about things very specifically in silos, which is a very traditional way of educating yourself. So fantastic. I mean, I love that's your takeaway from all of this. I'd be curious to know then, why do you think a student should do science fair projects? Why should they do a STEM project when they've got busy lives, they've got social lives, they've got other hobbies? Why is science fair and STEM projects something they should be prioritizing?
I think that I think students should consider a few factors when they think that they don't really have enough time for a science fair project, because I think they'll find a science fair project really rewarding. Like first, it fosters skills that can be transferred into learning at school or in other activities. For example, my project taught me not only new knowledge and logical thinking, but also patience as well as creativity to think outside the box. And that actually helped me with some of my school subjects as well as certain math contest problems. Secondly, like science fair projects, they allow you to dig deeper into the subjects that you're interested in and like take control of your own learning. It's quite different from, say, like school classroom learning, because in school, everyone's learning the same curriculum and you're learning the same things like math, science, English, social, maybe in options class. But with a science fair project, you can choose a topic that you're interested in and you become invested in that and you become a sort of expert in that topic. For example, I would have never learned how to code like this like fluently in C++ or build and fabricate that rapidly if I just took an options course at my school. But with just a few months of working on my science fair project, I had learned all of these different skills. I feel like science fair also creates meaningful connections between you and a bunch of cool people. Like from cold emailing, experts, lab visits, you can meet so many cool people that are trying to achieve the same result that benefits the future, but in different ways. And they're still really knowledgeable in that topic, but like it's just really cool to meet these people. For example, like when I was troubleshooting and trying to interview the population to get a better sense what the innovation needed, I was able to go into the UC Stroke Robotics Lab and meet Mark Pitts, who is doing really cool research on stroke rehabilitation. And I would have never gotten this opportunity if I didn't do science fair.
Cool. It is. It's a community of people that, again, as you said, have a shared understanding and a shared passion, I think, for doing something cool like a science fair project, but also, you know, you're also similar, and often that's hard to find in a local community, depending on where you grow up, especially. But it's just this wonderful community of people that are wanting to change the world, and you get incredible, unique experiences that you just don't get access to otherwise. Big question for you: why is STEM itself important?
I think STEM prepares people to enhance their problem-solving skills. So let's take math as an example, like the math part of STEM. It enables people to analyze information, eliminate errors, and make a conscious decision about what they're doing when they're designing a solution. For example, even though this isn't like really math, but physics is really related to math, right? In order to solve that unbalanced flight issue, I calculated the equilibrium point of the assembly for the drone center of gravity balance by using the knowledge I had learned from the AP Physics textbook. I think additionally, I believe that STEM can foster creativity. So it fosters and inspires more young people to generate new techniques and ideas. For example, it helped me think outside of the box. I know I've said it a lot of times, but I think it's really important, especially like when I was stuck with that arm raising issue. I spent days thinking of solutions that could possibly work until one day I thought of the out of the box solution, which involved flying up and capping the grip onto the doorknob. I think STEM is also like a view into the future, right? Like it prepares young people to be more ready to contribute to a revolutionary like tech future, and it gives people skills that makes them more ready to create new technologies.
Nice, I love that. So then, what comes next for you? Do you have plans for the future? Not to put pressure on you as a young kid, but are you thinking far into the future? Do you have an idea of what you might want to pursue?
I think for like career-wise, I think I want to go into like being an entrepreneur in the field of like aeronautics or aerospace engineering, because I want to be strong in science, engineering, and business. And I hope that I can continue my passion for innovation so that I can come up with innovative solutions, but also realize the innovation's full value to better people's daily lives.
Cool. I love that. So then last question for you, and then we can wrap up. But do you have any advice for people looking to get involved in science fair projects? Any advice on, how to choose, what to focus on, how to stay motivated?
I think I'm going to encourage like other students to start an innovation project. Just like start it, like use your passion and your skills to better the local community, because it's just so cool and meaningful to do that. My first tip, I guess, would just be to brave and take action. Like, I think a lot of my friends, like they have these ingenious ideas from time to time, but in most cases they just let it go because of their busy schedules or hesitate to even start. And I feel some regret because I think that those ideas, like they could change the world, but they just need to be brave and start it. My second tip is just about the mindset. Like, you can't think of science fair like a competition. Like, sure, awards get handed out, but it's called a fair and not a science competition. So creating these projects and researching in-depth different ideas is so amazing, and you can learn so much from it. Innovating something is also challenging in aspects of like knowledge, skills, and resources, but it's also sort of like an adventure, and it's kind of exciting. You have to be resilient, and you have to be able to take some of those failures, but you just have to persevere and keep on going. Last but not least, like when you see a tangible result, you will feel like the meaning of innovation. Regarding like choosing the topic, like the project topic, I just have one answer. Like, choose a topic you're interested in. Don't be constrained by what other people suggest you do or winning projects. Just choose a topic that you're invested in and you're interested in, because only when you're doing something that you're interested in is that when you can explore that topic deeper and persevere to create a meaningful project. Yeah, I think that's all.
I mean, that's a great place to end it on, for sure. I mean, wow, what an incredible last words of wisdom and advice for everyone. So, Max, thank you so much for being today guest on today's episode. It's just been full of amazing advice, inspiration, and wisdom. So hopefully everyone listening to today's episode can spend some time reflecting on that as they think about their own adventures in STEM. Truly, congratulations on an amazing achievement once again. I definitely look forward to seeing where your project goes to, and hopefully see you at Countywide Science Fair 2023 in Edmonton, for sure.
Yeah, thank you. And it's been a fantastic chat with you. And this has been like a great podcast to share ideas about science fair and STEM related topics. So yeah, thanks for having me here.
Of course. You're wonderful. Thanks so much.
Thank you.
Thank you all for joining us in this episode of Why to How, a podcast where we explore adventures in STEM. If you liked this podcast, consider leaving us a like on our social media. It's just ysc.sjc on Facebook and Instagram, YSC_SJC on Twitter, or join our Discord. It's Purple STEM Wave. You can find the link on our website, youthscience.ca. Please leave us a comment with your favourite part of the interview and let us know your own thoughts on the topics we discussed. And if you liked it, please do share a link to the podcast or YouTube video with friends who you think would love to follow along. And if you're on Apple Podcasts, leave us a review, as it really does help us reach more people. We'll have another amazing guest for you on the next episode, so stay tuned for more. Until then, have a wonderful day and stay curious.